The control plane of a traditional network element has evolved over the years, and as of today we find it quite complex because of we add different complex protocols over a period of time. Now SDN comes as a help to solve this complexity by introducing modularity and abstraction. In today's Knowledge Spark, we are trying to look at the complexity of a traditional control plane of a network element and how SDN proposes to solve that. Let's start from the networks in the history. Now, why the networking industry is lagging behind? Now, in those days, we had few protocols. For example, we had Ethernet as a layer 2 protocol or a data link protocol. We had Internet protocol or IP as a layer 3 protocol. And then we had things like TCP, UDP, etc. So few protocols, and the networks used to be simple and simple in operation. As we move forward, as the networking industry evolved, we realized that we need to have certain controls in the network. For example, we wanted to have traffic isolation. For that, we introduced things like access control lists, VLANs to separate different traffic types. And we wanted some more control. For example, we wanted traffic engineering because we didn't like the way IPs find their own way in the network, but we wanted to sort of traffic engineer the IP packets, their paths, and we introduced things like multi-protocol label switching and also MPLS traffic engineering, and we also introduce weights and sometimes equal cost multipath. Then we wanted certain packet processing controlling mechanisms, and we introduced things like firewalls and also network address translation. One reason is packet processing, but most obvious reason for that is the depletion of IPv4 space. Then we wanted to certain analytics controls, for example, payload analysis, and we introduced things like DPI. So because we wanted certain controlling in the network, we used to introduce different control requirements over the years. And that introduced some complexity. But the most important thing is these mechanisms were designed and deployed independently. So this resulted a much complicated control plane which is very much primitive in functionality. Now if you take our network element, which is having a forwarding layer, control layer, and multiple applications running on it, the conventional, the traditional network element, what happens over the years is that, for example, if this is a router, we kept on introducing different functionalities, different control mechanisms. For example, traffic engineering, VLANs, multi-protocol label switching, OSPF or open shortest path first, one of the interior gateway routing protocols, and then firewalls, netting functions, RSVP or resource reservation protocol, sometimes with traffic engineering, and layer 2 VPNs, layer 3 VPNs, IP version 4, IP version 6, etc. So what ultimately resulted was that all these functionalities were kind of baked into the infrastructure, which is our network element. So this is the kind of an industry with the mainframe mentality where everything is baked into one single black box type of thing. If you take the little bit of diagnosis into the traditional control plane, you will realize that the control plane has no modularity and limited in functionality. And also, for example, if you want to build a new routing algorithm, what are the options you have? The only option is start from the scratch. There's no way that you can do modifications to an existing routing protocol, but you need to start from the scratch and introduce a new routing protocol. So ultimately what this resulted was that there is no exact network abstraction, or rather no abstraction in the control plane. Whereas if you take the elegantly modular TCP IP stack or the data plane, we have applications built on transport, built on network, and networks built on the physical layer. So the data plane is kind of modular in its layers, where you have multiple layers, application, transport, networking, and physical in the most simplest case. And this allows, for example, to change the IP version 4 from IP version 6 or vice versa, because these layers are fully separate from each other. We lack abstraction, which is actually present in the data plane, but we don't see that abstraction in the control plane. Now, to give you an example, let's look at the ladder of abstraction using simple programming concept or a software concept. Now, suppose you have an application software. Now, application software is the one that you use for some work. And then you realize that you write the application software using a high-level language, which is human readable. And then you realize that high-level language is actually written on top of a low-level language, something like C. And the low-level language, if you look at, is actually running on bits and bytes, and those days we had these punch cards to give instructions. And these bits and bytes are actually represented by different voltages and currents in the digital world. And if you really look at, voltages and currents are actually governed by the laws of physics. So in this ladder of abstraction, when you talk about an application software, you actually start from physics, voltages and current, bits and bytes, low-level language, high-level language, and the application software. So it is kind of modular. So you abstract from bottom to top. Professor Barbara Liskov is a computer scientist and also a professor in MIT. She says modularity based on abstraction is the way things get done. So abstraction is important, modularity is also important, and modularity based abstraction is the way things get done. The fundamental idea behind SDN is modularity and abstraction, and the key idea of SDN, which is the separation of the control plane and the data plane, is actually resulted from this idea. We have the forwarding plane or the forwarding layer, we have the control layer with the network operating system and also the applications. We now separate the control plane from the data plane. This is how we actually tackle the problem of the control plane complexity and find a solution for that using SDN. That's it for today, and I hope it's now clear to you how SDN solves the control plane complexity. We hope to meet you again with another knowledge spark on SDN and look at some other aspects of SDN. Bye for now.
If you like this video and want to see more by Arctube, make sure you subscribe to our channel by clicking the subscribe button.